Okay, welcome back. Let me just get this set up. Okay, bear with me for a moment. I'm always putting my finger in the camera side. Okay. Okay. Just make sure I can bring this up, make this view. Don't want anybody straining the eyes to see it, so let's make it a little bit larger. Let me try 149. Yeah. Okay. Yeah, I think we can go with that. Okay, what I want to look at is Zener diode, okay? Or Zener diodes if you prefer, as we can be dealing with more than one. Right, one of the first useful theories on the breakdown of dielectrics. Now, the insulating material between the two conducting plates of a capacitor is called a dielectric. Was put forward in 1934 by Zener. Okay? Now, this is mainly to give you information on the background of the Zener diode. Okay, he suggested that under the influence of very intense electric field, 7 million volts per centimeter, electrons can tunnel through the forbidden energy gap. So it's almost like imagine that you're going into subatomic space and you are actually tunneling through those spaces that atoms leave to make up any material, basically. So that's what he's trying to say here. Now, has any of you seen Ant-Man, the movie? And if you look at Ant-Man and the Wasp, you'll see what I'm trying to say, okay? As they went into subatomic space. This is a similar thing what they're talking about here. This theory is certainly true in semiconductors, p-n junction diodes with a relatively thin depletion layer. Okay, p-n junction diode with a relatively thin depletion layer. When breakdown occurs with an anode voltage in the region of 2.6 to 5 volts, this kind of breakdown is known as Zener breakdown. Okay. With wide depletion layers obtained by modifying the impurities doping, breakdown occurs at a much higher voltage than is expected by Zener theory. In such cases, the breakdown mechanism is thought to be due to avalanche breakdown. The breakdown mechanism is explained as follows. Leakage current in the PN junction diodes is largely due to minority carriers drifting across the junction under the influence of the reverse bias. If the electric field in the region of the junction is sufficiently great, the electrons are accelerated and acquire enough energy to ionize atoms by collision. They do this by stripping off valence electrons to generate electron hole pairs in the depletion layer. Now you need to look at some of this yourself, and you need to go back and do some reading on electrons basically. Okay, don't just take it as read here, because trying to explain this to you without any prior knowledge is not an easy thing for you to grasp or to undertake. So please don't try to grasp this from one reading. It will not work. You must do some groundwork. The effect is to cause, sorry, one second, let me change color. I don't like the color at all. That will give me a problem in the change color. What am I looking for? Go with orange, dark. Okay. The effect is to cause a very rapid transition from a reverse blocking state to a reverse conducting state. Both avalanche and Zener breakdown diodes are both known as Zener diodes. Okay. Description of equivalent circuit. Diode D1 allows conduction in the conventional manner when the anode is positive with respect to the cathode. Conduction takes place through D2 when cathode potential exceeds the breakdown potential Vz. Resistance Rz represents the reverse breakdown slope resistance of the diode, which has a value between 0.5 ohms and about 150 ohms, depending on the operating point and the diode rating. The anode current of 4.7 volts diode is largely composed of carriers which have tunneled through the potential barriers, and the characteristics is typified by a smooth knee. Now you'll see later on what the knee is. Okay, it's just a curve. Avalanche breakdown diodes have a characteristics with a sharp knee, which is due to the sudden transition from reverse blocking to reverse breakdown, and the slope resistance is generally higher than that of a Zener breakdown diode. Okay. The voltage required for the avalanche Zener diode is higher because it has to overcome a greater resistance value. When breakdown occurs between 5 volts and 7 volts, there is a range of diodes whose breakdown mechanism is partly due to Zener effect and partly due to avalanche breakdown. Okay. The forward characteristics of both Zener and avalanche breakdown devices are generally similar to a conventional PN junction diode. It is found that Zener and avalanche breakdown mechanisms react in different ways to change in temperature. Okay. In Zener breakdown, the tunneling effect increases with temperature, resulting in a okay. We'll pick this up in the next section. Right, this is Zener diode lesson 1. Okay, Zener diode lesson 1. Okay, let me just take it back up to the top, make sure that I've got everything in place. Okay. Okay. I'm just recapping now, making sure that it's all in frame. And there we are. Okay. Thank you. I hope you found this useful. Okay. Have a good day. Bye-bye.